Right, so I'm going to show you the dangers of these dodgy plugs which are being sold. They should never have been used as they're non-compliant, even though they claim to be, with the numerous safety markings. First of all, just looking at it, you can see something's not quite right. If you compare it with a compliant plug, such as this one, and now this just happens to be grey moulded. If you see the massive difference, size, starters, spacing, the amount, and as well the most important thing, fuse. This is an unfused one, which is, well, is quite dangerous. Pins as well are on the non-compliant one, they're the wrong size. So this could actually lead to overheating when it's in the socket, because they won't be making a good contact. They can actually start heating up. You've also got sleeving on the earth, which could be quite dangerous. So yeah, and as well, before I start it, look at the size comparison. So both of these will be able to handle, well, no, let's rephrase that. This one, because it is compliant, will be able to handle the load I'm going to put through it. Well, I'm not going to put through it because nothing's going to happen, so there's no point me even showing you. Meanwhile, this dodgy one, it claims it can handle 13 amps. So we're going to take 13 amps through it, yeah, and see what happens. How I'm going to do this is I'm going to chop here and create a short. I'll use an ammeter to clamp on to show you what's actually running through it. But so yeah, this video is more probably to show you what could and will go wrong. As you can see, we've got our ammeter set up. We've got a short here. This is going to represent, let's say, a problem with, I don't know, an appliance problem. Obviously this is unfused, so it's not going to actually trip. So, well, the fuse isn't going to blow. So yeah, so we're going to pass through 13 amps to see what happens to this cable. If this were to be a conforming device, the fuse would go. Also, this cable would be able to handle 13 amps. So let's begin the test. Right, oh, don't worry, the electricity is off. So that test lasted, oh no, my ammeter. Oh no. So, as you saw, that test lasted a matter of seconds. Luckily my ammeter isn't that badly damaged. A bit wet though. So, oh, it's melted. Oh god, this is horrible. So, let me let's see. As you can see, the damage has been done on this cable, and if you look at the video, you can actually see that it only needed about just shy of half an amp to cause this much damage, which is really, well, it's I was saying this claims it can handle 13 amps. You can see this just, well, failed immediately. Also, this isn't earthed. The brown cable, which I think was supposed, even though it's normally supposed to be used obviously as a live conductor, for some odd reason they've tried to wire it in earth quite badly. It's move the cable, it just connects and disconnects. Black and black of black is your live and neutral. Obviously, I can't remember which one's which. I think the darker black one is live and the lighter black one's neutral or something. So you can actually see, if I pull this cable back a bit, this is a lot harder than I thought, because the actual outside sleeving has gone and melted into a million pieces. So yeah, you can actually see the extent of the damage. That's the inside of the cable. You can see that has obviously just started breaking down and melting. So I would imagine that would run through the whole length of the cable. Also on the video you saw the cable starting to flex around, which is obviously the cable heat. Well, when I took this out, the cable was very hot. So yeah, that is basically what happens when using a non-compliant device. If a fault occurs, that could be an outcome, well, most likely the outcome from what would happen. So yeah, I hope you enjoyed this video. I plan to make a couple more in the near future. I hope it was very informative. So yeah.